Perfect. So hi, everyone. Thank you for joining our Unlocking the Cloud Operating Model webinar today. I want to start by saying I hope everyone is staying safe and healthy out there. Today, we have HashiCorp's Global Field CTO, Brent Holden, on, and he's going to discuss the implications of the cloud operating model and present solutions to teams to adopt this model across infrastructure provisioning, security, networking, and application delivery. If you have any questions throughout the presentation, please feel free to put them in the Q&A portal. We have 15 minutes allocated at the end of this presentation for a live Q&A with Brent. So with that, take it away, Brent.
Well, thank you, Brianna. Appreciate that, and thank you everybody for joining today. I think we're always very appreciative that you're able to spend an hour of your time with us. My name is Brent Holden. I'm the Global Field CTO here at HashiCorp. Today, we're going to be presenting what does it mean to unlock the cloud operating model. I think first, what does that even mean? What is a cloud operating model? How does it apply to you? And then what are steps that we can take going forward, and things we have to be aware of. So this is sort of distilled from a lot of customer interaction that we have. My role at HashiCorp means I have to meet with a lot of technology executives, just folks that are trying to rebuild their organizations or design their organizations for the best delivery capability. So with that, I think, we won't stand on ceremony. I'll just say, if you want to throw your digital tomatoes at me, I'm at Brent Holden on Twitter. Pretty easy to find. So with that, let's talk about what's going on in the market. What do we see? What are the big macro trends? There's going to be some super obvious things, so just hang in there. And then some less obvious things, some more subtle changes that are going on. Okay, so here's the super obvious changes going on. You have a private data center. You are now augmenting that private data center with some public cloud provider. That may be Amazon Azure, Google, Ali Cloud, IBM, Oracle if you're unlucky. And the other cloud providers, I think some may be chosen based on your technology bias. So you may have just a lot of Linux compute that lands on Amazon. You may have a lot of Windows compute and .NET that lands on Azure, or data science workloads that land on Google. Some may be by geo. We see a lot of Amazon traction in the US or North America versus EMEA, which is primarily Azure, and APAC, which is primarily Google. It's just kind of an interesting mix. So I think you may be choosing a provider based on your preference or based on where you exist. So that's the really obvious thing that's going on. People are augmenting their capabilities using public cloud. I think the less obvious change that's going on is that we are driving now what we call systems of engagement. So what types of systems are we using on public cloud? Primarily what we see is that your old databases, those old ERP systems like Oracle, EBS, or SAP, or PeopleSoft even, they're staying on private cloud. They're probably not moving anytime soon. We do have a couple customers who are moving those, but only a couple. Primarily what's landing on public cloud is those systems of engagement, right? Those newer systems that are driving your front office and your customer engagement. They have to tie back into your private data center. And what we see are that those patterns are sort of reinforced by what public cloud is able to offer. If your customer demand is able to scale with demand, that's ideal. Private cloud is a little bit more challenging just because chances are you're running your private cloud at a much higher ratio consolidation. It has limited capacity, kind of by design, whereas public cloud has virtually unlimited capacity. And what we see is that it's the iteration, how quickly you need to deploy. That's another driving factor of public cloud. Okay, so those kind of exist within those static and dynamic changes that are going on. Now, what we mean by that is this. The static versus dynamic, it's sort of at every level of the stack, we see that there's an inherent technology change that has to go on. Now, with our old provisioning systems, those used to be dedicated bare metal machines, or virtual machines on top of a platform like VMware versus your on-demand capacity-based deployments, like, something like you may have, virtual instances on top of a cloud provider mixed with containers, mixed with serverless, right? So we have to start thinking about those compute resources being able to be spun up more dynamically with demand. The second layer, I think, is the hardest layer. Second layer is missing a label here. It's actually security. Security is easily the hardest problem our customers grapple with. I think it's fair to dig into this topic for just a minute. The reason why we see it as so challenging is because you're moving from a place you used to be able to drive to, namely your private data center. It had 4 walls, it has one network DMARC. You can plug into your firewall, and there is one guaranteed way in and one guaranteed way out. And there's a clear network perimeter because of that. When we move to public cloud, it's more that there's a logical perimeter. There's no clear perimeter. In the private data center world, if you wanted to expose a resource public, you'd have to call your firewall operations team and say, hey, we want you to either open this port, or call the network ops team and say, hey, could you unplug this Ethernet cable outside the firewall? They would say no and hang up on you. That would be the end of the conversation. But in the world like Amazon, where we can just tell an EC2 bucket, we want you to be public, you set the flag and EC2 says, okay, coming right up. And so there's like this clear differentiation of how things get public versus not, which just means there's no clear perimeter. And what that means is that we need to start thinking about security a little differently because the model changes. Part of that is because we used to secure things based on IP address. So you have things that are static, long-lived. You can assign them an IP, and that's how you track them through the data center. When there's things that are rapidly provisioned, like containers or serverless, those IP addresses may change. And so having this lack of clear perimeter plus these rapidly changing IP addresses that used to be our standard of security creates a lot of issues. So customers are trying to move more towards identity-based security because of that. The next layer up is how we connect applications, sort of in line with how we grant access to machines. It used to be host-based, so you assign in an IP, that's the way it gets tracked forever. On the other side, we're thinking more service-based. So the service gets an identity. The IP that it gets underneath should be a technical detail, right, of how we connect applications and grant permissions to each other. I think the last layer up is how do we provision infrastructure to run applications? In the old traditional world, it's the dedicated infrastructure. We're going to procure either a set of hardware or a set of virtual machines. That's where the apps are going to live. Versus on the new world where we no longer can think about a single instance because public cloud is really designed to be breakable, right? So you may have networks that go away, or instances that die, or security groups that fail. There may be things that happen within public cloud that you're not expecting, and you have to deal with that breakage. And because of that, we have to think about not scheduling an application on a single machine, but scheduling across a fleet of machines. That way, if something fails, we can reschedule it somewhere else. Okay, so those are the basic kind of tees up to the transition. Now, those are the sort of more of the obvious transitions going on. Yes, you're getting public cloud providers in the door. Yes, you're having to deal with these like different technology transitions going on. But I think the harder change that goes on within our infrastructure is actually not related to the technology. It's actually driven by our process. And that's what we're going to spend most of today talking about, is what does that new process look like? In the old world, primarily it's ITIL driven with an ITSM system to maintain that. And I think the best way to articulate that is everything is a ticket. So you need a resource, I need a compute, I need a firewall rule change, I need a load balancer update. Everything is a ticket that you have to process. And that's how we maintain the contracts between different teams. I think where we want to get to is what some customers call it DevOps, some customers call it CI/CD, some customers call it self-service. I think how we define it is DevOps is API-driven self-service. That's the fundamental process model change that has to happen. And so how do we get there? I think is the big challenge that most customers are trying to solve right now. Okay, so digital transformation is kind of a played out term. I hate this term. Chances are you probably hate this term too. We're just going to define it here and move on with life. The digital transformation that we see is that most applications that are being innovated on are the front office applications. Those are the customer facing apps, right? Chances are you have a mix of customer facing apps with your backend. Your backend is slower moving, it's more conservative. Your front office apps are being rapidly iterated on. And those are the things that you want deploys every, call it like every 5 to 10 minutes. Right? That's where you want that rapid iteration. Because of that rapid iteration, it's driving self-service processes. ITIL is largely driven by tickets and ticket queue processing and how efficient we are at that. That's really hard to move faster. There's only so fast that people can work. And I think the idea is we have to change our process model behind it. That's also driving cloud adoption. And so because we need to rapidly iterate on equipment, having just a system where you can make an API call, get instant access to resource, that's an ideal type of environment. So whether or not that's public cloud or private cloud, sort of up to you and the regulations that you have to live in, but that's what we see as being a driver. Okay, let's talk about what the challenge is. What does this actually mean? So let's be honest. HashiCorp thinks about, you probably know HashiCorp for the tools even. HashiCorp for, technologies like Terraform, Console Vault, and Nomad, as well as, maybe Sentinel, maybe Vagrant or Packers in the mix as well. But people know us for our tools. That's because when we think about technology, we tend to think about things tools first. That's usually not the way an organization gets run. An organization is not run by tools. It's run by people. And so the way that an organization exists now is that there are people, there are specialized skills. The way that they work together is largely how they define their culture. And then they sort of have KPIs associated with those behaviors. One instance might be that you have a ticket queue. One KPI might be how efficiently or how what percentage of time did you meet your SLA? It's an example of that. And the processes is how we enable those cross-team collaborations. So, okay, so if I wanted to, if I ran a compute farm and I wanted to give people access to it, okay, you're gonna have to interact with my ticket queue, and that's the ITIL method of doing things. It's not to say that's bad, it's just the way that we've always done them. And then we design for those KPIs that we want to meet, right? The last thing that we should think about, which is actually the first thing we think about, is the systems. The systems underpin the process. It's usually not the other way around. I think most customers look at the system, they look at the tool, and they say, what can this tool do and how can it help me? What we would recommend is just thinking about what are those processes that you want to adopt? What do those look like? And then have the systems underpin those, right? And so the tools can get very religious, they're very philosophy oriented, but they're just there to underpin the processes. Now you may be saying, okay, well, we're going to solve all of our IT challenges, on the people side with the unicorn. I hate to break it to everybody, this person does not exist. If they did exist, you probably couldn't afford them, honestly. It's just one of those things where there's not very many of these people out there. You can't build an org around the unicorn. There is no human who knows all these topics: development, operation, networking, security. And even if there was, you wouldn't want your entire org bottlenecked through that one person. And so there's the problem of scale, right? If you're like a 5-person shop and you have the unicorn, great. But if you're a 1,000-person shop or a 10,000-person shop, it's a much different problem if you only have one of these folks. So this is the fundamental challenge of breaking this person's skill set down. And so what we see is that customers have this new definition of the specialization of labor. So there's not one human who knows all these different topics. There's several people who know these different topics. And it's really about crafting their focus and what should their skill set be. And then also defining how they work together, right? So for the developer, it's really around more service ownership. They're granted a lot more autonomy within the environment. They're no longer throwing their application workload over the fence to the operations team. Because of that, the operations team, because they're no longer having apps thrown over the fence to them, they're taking a different type of approach. Their approach is more on developer enablement. And we see this increasingly important role in terms of what we call SRE. SRE stands for Site Reliability Engineering, which is a term that was pioneered at Google. And the role of SRE is really around automation and focusing on that role and making the developer experience easier, better. For the networking folks, it's more being application aware, not just focusing on levels 1 through 4, focusing up the stack, being more level 7 aware and service aware. I think the hardest change, which I alluded to earlier, which was a security change. So moving more towards being identity-based, no longer IP or host-based. I think that's a very big challenge. And also, security needs to just be integrated as part of our development lifecycle. We can't just have it as the checkbox at the very end. So we have, the individuals are organized into a team. Processes are just how we scale. right? So, in the idea is that we want to change the processes of how we work together as teams. So let's just do a quick recap of what your ITIL processes look like today. What does that mean? When you have developers who want to come in, chances are when they want to deploy their app, they're going to talk to your compute team and say, hey, I want a compute resource. They file a ticket. And the compute team says, okay, coming right up, we'll be here in 2 weeks. And so 2 weeks later, the compute resources are there. And then the developers have to go to the firewall team and they say, hey, firewall team, I need some rules opened up. Firewall team says, okay, yeah, coming right up, it'll be about 12 weeks. Right, so 12 weeks later, their ticket is satisfied, they have their ports opened up, and then they go to the load balancer team and say, hey, by the way, I need a load balancer and I need these instances attached to it. And, great, that'll be here in 8 weeks. So I think the overall time to value from the developer team's perspective is roughly 22 weeks. It's a super simple way to think about it. I think realistically, that's what the developer cares about, is what is that time to solve their problem, not how many steps do I have to go in the ticket queue depth. And so just as a sort of a recap of this, we talked to a major US telco. You've definitely heard of them. I'm not going to call them out. It's a little embarrassing, but I think it's just reflective of like, what does this look like at scale? And their application deployment process was 72 plus steps, and it took roughly between 10 and 11 months. And nobody, I think, wakes up in the morning thinking, I'm going to build a process that's 72 steps long. You have to fill out 72 different tickets, and this is how you get work done. Nobody does that. But it's kind of how we've always done things. We have a technology that we bring into the data center. We assign an owner in the form of a team. How they work with other teams is a ticket. And then just over time, it just builds up to a point where it's just really painful to get through the ticket queues. And so now we have like almost a year lead time for applications being delivered, which is just too long. And so the existing principles that we're operating under are that each team has an owner, is an owner of their own technical domain. And so they're organized around, what is the compute team, what is the firewall team, what's the load balancer team. They all own their own individual technologies. And then they are gatekeepers of access, meaning if you want one of their resources, you have to go through them via the form of a ticket to get access. And so those have to change. And the change is not thinking about things in terms of what is the process, or not in terms of what is the technical resource that we need, but what is the process my customer is going under. Usually it's an internal customer. So what does their end-to-end process look like, and how do we deliver great work to them? I was thinking about things in terms of a process domain rather than a technology domain. The other is, how do we enable self-service, and how do we enable that API-driven access? I think that's sort of the goal, right? Public cloud made that really easy. Now customers are looking at taking that same process model and applying it to all their technologies, not just access to Amazon or Azure, Google. Okay, so DevOps processes inherently have to change to this. You want, instead of having a compute team, now you have a provisioning team. And the provisioning team is fronted by an API. Same thing with the security team. They're interacting with an API. That's how work gets done with them. It's an API call. It's no longer a ticket. And same thing with the deployment team. They have an API that's in front of them. And so what that means is that we're necessitating the creation of these new systems to underpin what do those APIs look like. And that's going to underpin our new processes within our data center. Okay, so there's obviously multi-layered impact in here, starting from like the tools up, going from API-driven cross-team coordination. That's where the tools have to have the most impact, because the tools just underpin our processes. The processes are now self-service enabled and also oriented around our workflow. When we say our workflow, that means instead of going through each different step for compute, firewall, load balancer, now it's a provisioning process where we're provisioning all those things at once in one API call, and going from like 22 weeks down to 5 minutes, right? So that's a workflow orientation. And because of that, we need to start changing people's skills. We need to think about, how do we get them oriented around creating automation? How do we promote autonomy, right? And not being that gatekeeper anymore, but being responsible for the resource, but also responsible for how people access it. Okay, so the systems of coordination, we sort of talked about this to death, right? The developer files a ticket against the operations team. That's how they get their application deployed. And now we want to move things towards an API-driven system. This is inherently the cloud operating model. The public clouds provided this in terms of they have a platform, it's got an API. Most developers don't want to interface directly with the interface. They just want to make an API call to provision their app. And so now we're bringing those same theories back to our on-premise workloads as well. And what's interesting is that this also becomes the new coordination method. So whether it's like your security team applying policy for what gets deployed, as an example, you may want to have the operations team maintain the integrations with, like, let's say you have a developer team that wants to provision things that live partially on your private data center, partially on public cloud. They should be able to make an API call to the provisioning team and that provisioning system to say, I want these resources. The security team should be able to apply policies to that new system that says, here's what you can and can't do. Here's what's within compliance. I think that's one of the key challenges. And this also means that the system is now our new point of coordination. Okay, so a lot of buzzwords in there. We're going to go even more, which is probably pretty exciting for you. So let's kind of run through them. One of the top buzzwords that we hear is the infrastructure as code. I think HashiCorp pioneered this. It's one of the reasons I work for the company today. And realistically, I think the old model was the developer team would file a ticket, the operations team, just, you know, whether it's a vExpert or whatever you want to call them on the other end, they're pointing and clicking within the UI to then create the resource. The new method is to have a developer team that interfaces with an API. And what they're making is effectively a pull request for code, and the code that gets processed with their system. And it has a couple of very kind of obvious benefits to this, which I'll go over in just a minute. But I think that's just the new model, which is the operations team has this API in front of them, and then the infrastructure is defined in a way that's documented. And so the couple of benefits that maybe are not super obvious about infrastructure as code is that it splits the execution from the definition. What we mean by that is that when you create a ticket and you say, hey, I need a couple of VMs that are created, your execution, your definition are sort of conjoined. When we define infrastructure as code can range from a wide number of services. And so what we're doing is we're defining what is everything the application need to be deployed, and it creates a standard definition that is documented and consistent. We can also use that to scale as we need, right? So in one way, maybe a developer making a pull request saying, hey, I need this application type filled, but I'm going to fill in all the blanks for you and give you what that Terraform code snippet looks like. In other ways, it may be, hey, I want to provision the Java app on top of AWS. And then that's something that you can just stamp out sort of assembly line style, right? Other teams can reuse that. Okay, one of our next challenges is the theory of identity-based security. I think just inherently, we talk about web servers trying to talk to databases is a very common pattern. There's always a firewall put in front of the database because they want to limit who is able to access the database. And it's this common problem. And so we have to maintain this list of rules that says, you know, inherently it's the web server wants to talk to the database, but how we maintain that integrity is we focus on the technology detail, which is IP1 can talk to IP2, right? And that's fine if it's only one system, but all of a sudden when you start scaling your web servers, well, then you have to start adding additional IPs that can talk to your database into your firewall, which means you have to constantly have tickets updated against your firewall. Now, if you have multiple databases, that's another inherent challenge, is where it becomes a multiplication problem. And so as you've been scaling up web servers to access those databases, you're going to maintain basically the IP rules from hell. And I think that's the basic reason why when customers look at their firewalls, they have roughly 10 million rules. They couldn't tell you what 99% of them do because it's all focused on can IP1 talk to IP2. And what's really lost in there is sort of the intent. The intent is we just wanted our web server to be able to talk to our database. And we need to be able to do that across multiple applications. Okay, so with identity-based security, we still have this notion of that the firewall is not going to go away. There's different ways you can solve that problem. One is you have the firewall look at a registry to then update itself. So that way you're not maintaining this, IP address matching via tickets that get filed. What you're doing is you're saying, listen, my web servers have this identity. When they get spun up, just update my firewall so that way they're able to access my database. That's one way to do it. The second way to do it is that the web server in the database actually has an identity certificate. And on each side, they're checking against the registry. Does the web server have access to me, right? If it doesn't, I'm going to drop the connection. If it does, I'm going to allow the connection through. I think that firewall functionality is not going to go away. That firewall functionality gets munged into the registry, in that sense. And so what that means is that with identity-based security, we're focusing more on what is the intent, like can the web server access the database, not can is IP1 able to access IP2? What that does is it enables dynamic infrastructure. So anyone who has that certificate can access the database, or we're addressing that scale challenge with automation. The other side is that allows us to improve our security posture. So most company networks are very flat, even though they're different, they're zoned in different ways. And it just means that by allowing us to adopt host-based security, we can do things like upgrading to mutual TLS when we connect to applications, and that'll improve our security posture. So service discovery and service mesh, the automation network middleware, that's where most customers start. The tool that I'm talking about specifically here is called Console, where most customers start with Console. They create the registry. The registry has visibility of all those different services, and who needs to talk to what is the intents that you maintain within the registry. And what we're able to do is automate off of the registry. So we have integrations with F5, for example, that we announced. We have upcoming integrations with things like Fortinet and Cisco that we're working on now. And so part of that is just updating things in an automated way. The second is getting rid of that network middleware. So do we really need things like firewalls and load balancers? How much of that can be pushed into the registry, that functionality? That's where service mesh comes in. And so service mesh is highly useful for creating those rules of what applications can talk to each other without putting firewalls into the middle, and using those host-based certificates to enable security between those different apps. Okay, so we also should talk about containers. What technology presentation would be complete without it? Containers are a great deployable unit. It's meant to be portable. I think that's their main value add. It allows basically a supporting set of infrastructure that you can use to work with this deployable unit rather than just shipping tarballs around everywhere. And so most container platforms, the developer team hands over the container to their operations team, and then there's manual deployment. This is the way it worked with tarballs as well, or just there's myriad of other things, other artifacts that got built with this. We want to change that. And how we change that is by giving developers self-service access via API, where they can take their container and say, I want the platform to run it for me. And that's it. Our container platform for that is called Nomad. And so what we're doing is we empower developers for those self-service deployments, meaning that everything is API driven, and we're consistent and scalable for operations. So that way the operations team is not constantly wrangling with the platform to get your application deployed. I think so what that does is it creates a new dividing line. One line is, above the line is really application. The developer team has this app and they have this build artifact. And below the line is the infrastructure that supports that. How do we get the app into production in a way that hides secrets from source code, in a way that means that we don't have to go through the 72 tickets to get my infrastructure created. Now, I think one of the basic challenges that if you're going to give developer teams more autonomy, you have to give them observability. What that means is that they need to be able to understand what's going on within the platform, to be able to troubleshoot what is going on within their app. They can't troubleshoot what's going on in their app. They really are kind of flying blind, and it's hard to give autonomy to teams that just don't have that kind of visibility. So that's really one of the key features of that kind of autonomy, and that's an area where you'll see major investments coming out from HashiCorp in terms of how do we interact with observability tooling in the future? All right, and so the whole goal is just developer teams are no longer contingent upon operations teams. They can deploy their own app. They can make sure their app is up all the time. They're the ones troubleshooting their own app. Effectively, you're handing the pager from the operations teams back to developer teams. Okay, so let's talk about how some customers have successfully navigated this transformation. Okay, so some customers, you probably name them, they get up in front of the whole group and they say, okay, we're adopting cloud and DevOps. This is kind of like the Big Bang approach, we call it. Very, very rarely has it been successful. Most of the time it's because you're taking an existing ITIL org and you're effectively changing the middle layer. What is the process without really thinking about how do we have to, bring new people into the organization, or what kind of new skills they need to have? What sort of new tooling do we need to have to underpin these new processes? Right. And so the same CIO that will say like, okay, we're going to adopt cloud and DevOps will say like, by the way, we get measured on business continuity, so don't break anything. Right. And, the challenge is that most operators, if you look at how they spend most of their time, their KPIs are all around how efficiently do we process metrics and do we meet SLA? Are those tickets being processed on time, and, are our customers happy? And they just don't have enough time. You really look at like kind of how you break it down. If they're 90% busy all the time is processing tickets, that's only 4 hours per week that they're able to investigate these new things. It's just not enough time, right? So they're 90% focused on just keeping the business running. The other 10% just is not enough of an investment. And so what we see being successful is if you look at the process model, you have the ITIL organization. If it were a tree, it'd be like a sequoia, right? It's got kind of layers of rings, and sort of somewhere in the middle there is mainframe with like UDB, right? And the new DevOps organization is really rooted around those new systems and those new APIs, that new API-based way of accessing. Instead of being a technology gatekeeper, now we're an enabler of resource consumption via API. That's what the DevOps org is all about. What we see is over time becomes like a contain and drain. I don't want to say that ITIL orgs are bad, because they're not. DevOps processes are sort of the way that front-end applications want to be created. And the ITIL orgs still have a function. They're never going to go away. There's going to be certain apps, certain functions within your data center that are always going to be contingent upon ITIL processes being there. But over time, we see more applications moving towards the DevOps style way of doing things, just because you can do things a lot faster. So one study that we have is that it's, for anyone who's familiar with like the Apple credit card, it's all backed by Marcus at Goldman Sachs. Now the technologists at Goldman Sachs are extremely talented. That is an extremely talented group. They're some of the best in the industry. What needed to change was not their technology skills per se. What needed to change was their process model. I think that was a key difference between how Marcus was trying to approach their go-to model at the beginning versus what was different at the end, was that their process model for creating infrastructure and how fast they moved changed. You could say the same thing about CapitalOne. I think most people are familiar with the CapitalOne story. Their CEO was on stage in Lady Jassy saying we're being public cloud in 2 years. That just didn't happen on their timeline. What they decided to do is sort of look at what business unit can drive the most value, which was at that point credit card. How do we change their mobile engagement model? They seem to move a lot faster when doing this. And what that meant was that they needed to look at basically every single step, their processes, their tools, the people, and how they support that. CapitalOne is a great story, just in terms of the broad spectrum of change, right, when adopting public cloud. So what realistically, I think Gartner was not so far off. Bimodal IT was kind of one of those buzzwords that existed for a long time. Mode 1 and Mode 2 were not really so far apart. It wasn't quite painted the way that they wanted to, but it does fall into what does an ITIL org look like and what does a DevOps org look like. And I think realistically, you may even have apps that sort of cross the two, where you may have the core of an app is more ITIL-based, more ticket-based, whereas Mode 2 and DevOps-based is the rapid iterating parts of an application. So you may even see that mixed mode with applications. So it's not an either or. type scenario. So here's the basics of what we see as success. One of the key success patterns at both Marcus and CapitalOne were that they had executive sponsorship. Executive sponsorship, is necessary anytime you make any sort of broad changes. Tooling can, be decided by a technologist, but process model and people training has to have executive sponsorship. There's also a clear alignment with the business group. I think I kind of skimmed over what CapitalOne's look like, but both in the case of Marcus and CapitalOne, both business groups were highly aligned with what business value they were delivering. So that way at the end, they could say, okay, well, here was the impact on the business that we had by our ability to move faster. The last is, how do they get from ITIL to DevOps? I think you have to really think about how you staff that org and what does that new DevOps org look like. If you're staffing the org with all the folks who created your ITIL processes, chances are your DevOps org is going to look a lot like your old ITIL org. Now, it doesn't mean they're bad people. It just means they have a certain way of thinking about the problem. So you have to think about how do you bring in some new blood, so to speak, to that organization and make it so that they're able to approach the problem a little differently. Okay, so here's the conclusions. We're going to wrap up in just a minute. There's a multi-layer impact, people, process, tools. Most people focus on the tools first. We would encourage you to think about the other layers of the stack. For the people problem, you have to hire people who are more cloud native, people who just kind of grew up in that type of environment. If they didn't grow up with it, you have to invest in retraining the folks that you do have on staff. There's going to be people who think about what does that process model look like and what is the end value. You're always going to find those people in the org. It may not be everybody. There's going to be some people who are going to fight you tooth and nail on why does this process model have to change, and you have to identify those change resistant staff. In some cases, they're going to come along the journey with you. In some cases, they're just not going to change. They're going to be a hindrance. And you have to figure out, do those people have a place in my org as it continues on? I think you have to rethink the process model. So we talked a lot about, the shift to being a more, API self-service driven model instead of ticket-based. Anytime you see a ticket-based process, that should be the exception, not the rule. If it's a ticket-based process, it should be a flag. You have to design around what do those API calls look like, and what does that workflow look like. The technology underneath is actually not as important as you think. It is important for the end delivery, but it's really that process model that has to be, first and foremost thought through. You have to think about what are those new systems are to implement those new API, self-service, automated workflows. If you're designing for heterogeneous environments, I think that's going to be a long-term winning strategy. If you're designing for a homogeneous environment, you're going to run into a point where you're going to run into limitations. I think practically speaking, we had some customers who, they invested very heavily in Amazon. They got to a point where maybe they didn't want to invest in Amazon for everything, or they wanted to have a bifurcated strategy with Microsoft Azure. And because they didn't think about supporting heterogeneous environments from the get-go, they effectively had to do a lot of rework, thinking about how does that automation work across these different providers. And you have to also accept that this is going to be a journey. The journey for VMware adoption, people started in earnest in roughly 2003 to 2005. Somewhere around 2013, 2014, they were mostly done. Still, there's some customers that we have that are only, call it like 20% virtualized. So you have to accept that it's going to be a journey. You can't change people and processes overnight. Chances are you're going to have to create a separate org and then drain things over time. And to do that, you're going to have to align to groups with a high business value. That way you demonstrate value to the rest of the company. So that's it. That's all I have. I kind of blew through a lot of slides, so I'm happy to answer questions that you might have. But I think Brianna, if you have any questions, I'm happy to help field them.
Yeah, great. Thank you, Brent. So now we'll go into the Q&A portion. So again, if you have any questions, please put them in the portal. We did get a few while you were presenting. So the first one is, what percentage of companies do you feel are leveraging service mesh successfully?
That's a great question. I think the challenge with service mesh is a pretty new technology. So what we see is like the percentage of companies that have it service mesh enabled sort of broad spectrum throughout the organization, probably zero. realistically. You see it in pockets, right? And the pockets are that service mesh is really designed around microservices. So for organizations that are leveraging microservices, they may have pockets of it. So you may see like instances of, Istio being one, AWS App Mesh being another, and Console Connect being our preferred solution. So I think that the percentage of companies is, for just service mesh everywhere, pretty low. But I think that they are working at it through basically like a cluster by cluster approach. And they're trying to look at how do I support that heterogeneity in my environment. I think that's what most customers are trying to work through right now.
Okay, great. Another one that came through. We're new to DevOps and cloud, but are doing both in pockets of our business. What do you see as the quickest path to value for an organization like ours? Focus on infrastructure automation and standardization first, or security issues?
I think sort of in line. I mean, like, it's a good question, Brian. The challenge is addressed by both. Like, we've seen customers do either. Some customers approach it in terms of like, how do we look at what does that developer lifecycle look like, and how do we provision things to different infrastructure? So they address that problem first. I think the problem with the highest business value is usually around security. So in terms of where funding goes, in terms of where your biggest risks are, you want to make sure that those secrets are secured. We still have a lot of customers who still deploy code onto a GitHub repository or VCS that still have secrets in them. That's usually the first place people go when they're trying to get access to your systems. So I'd say in general, there's like a basic health to just security within the org. Most customers usually start there, but I'd say that for some customers who are already starting to address that problem, the next step is what is the what does the health of my organization look like in terms of our process model? For customers who are investing in Terraform, I'd say Nomad and Console are usually shortly thereafter to follow.
Okay, awesome. We got a question in the chat. So what tools and technologies are being used to drive the front end portion of self-service API driven, i.e. to kick off Terraform?
So that's almost like a planted question. It's so good. So I would say that what we see is some customers, they're going to have a hard time moving away from ITSM. And so we have integrations that we announced with ServiceNow, for instance, that ServiceNow can front Terraform Enterprise, for example. That way you can just pick out from the catalog, hey, I want Java on top of Amazon, or I want .NET on top of Azure, or whatever your patterns are. You pick a pattern, and you can use Terraform to execute the deployment. The pattern is just enabled in a service catalog with ServiceNow. Some customers, kind of the beauty of both Terraform is that it allows different interaction models. So one model might be like a service catalog. One model might be some teams just need more access to an environment. Like, for example, we have one customer who, they need to support people who are very low skill, so they need to just like deploy the environment. Some of their internal customers are very high skill, so all they want to do is they just want to create like an account with a landing zone in AWS, and they want to give some basic network parameters to the account and let them kind of run wild with everything else they're doing. Right? So I think that there's different interaction models for different teams based on their skill level, which Terraform can help support. Hope that answers the question.
Yeah, it doesn't look like any other ones have come through. If you do have any other questions, please feel free to email me and I will route you to the right person. So I'll put my email in the chat. So just want to say thanks to Brent for joining today, and thank you all for joining the webinar and listening in. Within a day or two, I will have the recording out to you with a thank you email. So thank you again for joining. We hope you enjoyed learning about the cloud operating model and how to tune the people, process, and tools to it. So with that, we're all set. Thank you.
Thank you.
Bye.